Have you ever wondered who discovered the electron? Allow me to introduce a brilliant physicist, J.J. Thomson. It was the year 1897, and Thomson found himself fascinated with the mysterious cathode rays. In his laboratory, he conducted experiments using a cathode ray tube, a sealed glass container with two metal plates. By applying a high voltage, he noticed a stream of particles shooting from the negatively charged plate, or cathode, towards the positively charged one, the anode. Thomson's keen observations led him to propose the existence of these particles, which he realized carried a negative charge. And so the electron was born. This groundbreaking discovery turned the scientific world on its head, for it contradicted the then popular belief that the atom was the smallest unit of matter. Indeed, Thomson's work opened our eyes to the subatomic realm, challenging and expanding our understanding of the world around us. Thomson's discovery marked a significant turning point in the field of atomic physics. So what exactly is an electron? Well, electrons are subatomic particles, meaning they are smaller than an atom. They carry a negative electric charge, and they are one of the three fundamental particles that make up matter, along with protons and neutrons. But electrons aren't just tiny, negatively charged particles floating around. They have a big role to play, especially when it comes to electricity and magnetism. Electrons move in a flow to create electricity, and their movement also generates a magnetic field. Now, in the realm of chemistry, electrons are the stars of the show. They participate in chemical bonding, determining how atoms connect to form molecules. Electrons also occupy specific energy levels, or shells, around an atom's nucleus. And these shells determine an atom's chemical properties. So, in essence, electrons play a crucial role in the world as we know it, from powering our devices to making life possible on Earth. Our understanding of electrons has grown dramatically since Thomson's time. The development of quantum mechanics in the early 20th century was a game changer. It gave us a whole new way to think about and understand the tiny particles that make up our world, including electrons. In this revolutionary model, electrons behave not only as particles but also as waves, a concept known as wave-particle duality. Imagine tossing a pebble into a pond. The pebble, like an electron, creates ripples that spread out in a wave-like pattern. This duality allows electrons to do some pretty strange things, like exist in multiple places at the same time. Then there's the uncertainty principle, introduced by Werner Heisenberg. It states that we can never know both the exact position and momentum of an electron at the same time. The more precisely we know one of these values, the less precisely we know the other. From a mysterious particle discovered in the 19th century, the electron has become a fundamental cornerstone of modern physics and technology.